Very good afternoon to all of you. Welcome to this demo session on data engineering. I'm Dr. Nilay Kerde, mentor for today's session, and on the behalf of Jai Raju and Akira IT Infotech, I welcome you to this session. So before we start with today's session, let me quickly take you through the agenda of the session, and then we will have a brief introduction uh, of mine followed by you. So we are going to start with introduction to data engineering. What is data engineering concept? Okay. So rather than starting with boring technical complex definition, I will explain you the concept with a real world example. Okay. Followed by that, I will take you through a concept of cloud computing. Now, if you pay attention on my agenda, you could see that all these are different topics which are taught across the course, right? And each one requires hours of teaching and implementation as well. So my aim here in this particular session is not to teach you a single concept, because thereby you will not get an idea about my teaching approach. So that's why what I have done is that in this particular demo session, I have considered 3 4 different topics. I will be spending about 10 to 15 minutes on each one of them to give you essence of what is the use of that particular tool, service, or technology, and how it works, right? So once I'm done with the introduction of data engineering, I will explain the concept of cloud computing, how it is useful in the context of data engineering, followed by distributed computing systems, how they are quite useful when it comes to building scalable data engineering solutions, because we know that nowadays we have a big data, right? Because of grassroots penetration of internet and digitization, we have got mobile phones, apps, and whatnot. So we are generating data. It is not just the volume of the data, but also the velocity at which the data is getting generated is quite high. And traditional tools such as Excel or any other database server, they are not sufficient enough to handle such a vast variety or volume of the data. So to handle this, I will explain you what is distributed computing system. And in our data engineering course, we are going to implement such systems using a big data engine called as PySpark, Apache PySpark. So most of these topics are basically, I can say, they are kind of theoretical topics. Followed by that, I will give you a glimpse of Python programming. So we will spend some time on basic programming concepts like how to create a variable in Python, how to do computation, how you can write a code to handle any condition from real world scenario, right? So there you will get an idea about how you will learn Python based coding, and then followed by AI ML example with PySpark. Now it is not possible to cover this particular topic in a matter of 10 minutes, so I will not cover the PySpark implementation of AI ML. Rather, I will explain you the working of one machine learning model, AI model, called as linear regression. Now, let me briefly introduce myself. I'm Dr. Nilay Kerde. I have done a PhD in artificial intelligence after completion of my master's in. I have done PhD in AI, and after completion of my master's in computer application, I have over more than 17 years of experience in the field of software industry as well as academia. So when it comes to academia, I have taught, I have taught students in university college setup, as well as I have given corporate training sessions to IT professionals as well. And these are my area of specializations: data science, data engineering, web, mobile app development, and AI. All right, so I think we are done with the introduction part. So let's move to the uh, our first point on the agenda. There you go. What was our first agenda? It was about an introduction to data engineering, right? Now you might got confused because of the slide that you see on my screen. I'm asking you about what is your favorite ice cream? How it is related to data engineering? Well, as I have told you, I believe in, uh, you know, uh, in a simpler explanation rather than, using those technical jargons and explaining you a complex technical definition. So let's use this real world example and try to understand what exactly a data engineer or data engineering means. Yes, so what is your favorite ice cream flavor? Well, those who are located in India, summer is gonna start, right? So I'm sure there must be a lot of ice cream lovers over here. Well, if you talk about me, my favorite is vanilla. Okay, people are saying strawberry, chocolate. Okay, okay, I can say that just two people are there who are fond of ice cream. That's quite interesting for fact for me to know, because I thought that majority of the people will be into ice cream. Okay, fine. Yeah. So you might have heard of a company called Amul, which are into the manufacturing of milk and milk products, right? So in recent year, they have recorded a revenue of 6.5 billion US dollars, right? So imagine a scenario that in one of their major manufacturing unit, a big machine, which is which is used for axle manufacturing, goes down because of some technical reason. And what will happen in that case? In that case, you know all their production line will halt, right? As a result of which it will impact their sales, their raw material. There are chances that their raw material may get damaged, right? So it's a quite costly affair for them, right? They can't uh, have such breakdown of system on a regular basis. So what they can do is they can apply, they can fit they can fit some sensors with these machines, like temperature sensor, maybe a sensor which measures the uh, pressure, temperature, or vibrations, etc., right? And all those readings, you know we are going to save all those readings into some data, uh, into some database. So it could be your database server, it could be your simple text files, right? Or even a cloud-based setup. What to do next? Well, whatever data you have collected, it can be analyzed by a data scientist or a data analyst. Real world data usually is quite messy, right? And there are a lot of scientific ways to properly clean that data. So data scientist will take care of that. Once the data is properly cleaned, we can feed that data to AI ML model. Now, what is AI ML model? Well, these are nothing but mathematical models, right? And these mathematical models learns the underlying pattern from the data, remember those patterns, and then make predictions for the future new input. So once this AI ML model has been trained, it has been properly trained on the given data set, then in the future, from all that sensor data collected, it can predict the maintenance of a machine beforehand. So it is quite good thing, right? Instead of getting that machine breaking down, getting damaged, and then you have to wait for a few hours or maybe for a few days to get it repaired, right? So instead of that, we can have a short period of, we can have a maintenance activity which take relatively shorter time, and thereby we are we are helping the businesses to streamline their operations, maximize their revenue, right? Now, in this entire example, where do you think data engineering is applied?
Data analysis and cleaning.
Okay, data analysis and cleaning. So now please read the first line, which is about the definition of data engineering. So just before data scientists start, doing the data analysis or data analytics, you know, the person who take care of extracting the data from the source. Now that source can be either Excel file, text file from the cloud, or maybe from the database servers, right? And then transforming it. So sometime, data may not be in the proper format. Maybe it is in JSON format, but the data scientists need it in tabular form, right? Maybe they are using NoSQL database, right? So you need to convert that data into tabular format. That is one use case. So a lot of data transformation methods are there. As we will progress in the sessions in this course, you will come to know about them. And then load, ETL. E stands for extract, transformation I have already told you, and then finally load. So and then load that finally, a better version of data, so that that data can be used for further data analytics, reporting, or for AI model development. And then using all these things, big businesses, big enterprises, they can make data driven decisions, right? So that is the essence of data engineering. Build reliable data infrastructure, transform raw data into business ready insights, ensure that data accuracy is there, right? And as I was telling you in the beginning of my session, it is very important for data engineer to build scalable solution, because most of the enterprises nowadays, they are having, terabytes of data. Sometimes the velocity of data is too fast. You have to process the data, and then make decisions in real time. So to build such scalable system, data engineer have to also consider this particular fact. We could see penetration of AI in almost every domain. So definitely, the ultimate end result of your data engineering solution, it could be also in the form of some AI initiatives. So I hope that the concept of data engineering is clear to all of you. Simpler manner, I will tell you what you are going to learn. So on the left hand side, what you see is a list of tools. As it is a practical oriented subject, so we will be spending a lot of time on coding, then how to use different services from cloud platform like AWS. Sometimes you have to perform the installation or configuration, do the configuration of a particular software system. So everything is covered in these sessions. I strongly believe in learning by doing, rather than you just looking at my screen and following the concept. We will also have some additional examples for the practice, and at the end of each session, I will provide you the relevant study material like code files, data sets, installation guide if applicable for that session. Okay, so that was all about the introduction part. Now I'm switching to a concept of cloud computing. Okay, so as I always do, I'm going to tell you a story, right? And then through that story, I will explain you what is cloud computing, which is integral part of your data engineering project. So let's say you want to build your own startup. So let's say I'm gonna start a startup called xyz.com. Okay, just a random name I have taken. Definitely, I will build a web application. I will have a database. All this thing installed in deployed on my server machine, right? A computer server machine. And what my clients can do is that they can simply type this URL in their web browser. The moment they enter this URL, their computer will send a request to my server asking to access that particular web application and relevant data. So this particular web application, it will process this request, and as a part of response, it will send the uh, you know data or web pages back on this client machine. This is a simple client server architecture diagram that you might have studied in your graduation, or you might have been you are already aware of it. Challenge before me is that, let's say, maybe during a festive season, or maybe because of the good service that I have provided, the number of clients are increasing. Maybe earlier there were just few hundred, but now I have got, let's say, 2000 to 2000 users accessing my application on daily basis. So what I can do is, I will just maybe in my home itself, or maybe in my garage, I will set up this infrastructure, the server machine, and then people can access my website. But what if over a period of time my application, my startup is getting more traction? Then in that case, to handle such a vast amount of request, I need to scale up my infrastructure, right? Now, when I scale up this infrastructure, there are few challenges before me. Upfront, I have to do a lot of hardware investment, right? I will need a space, right? Uh, I will need to rent a space to to maintain this infrastructure. I will need uninterrupted power supply, air condition system, and even hardware engineer or maintenance guy who will take care of this infrastructure. So you can see that uh, at you know I have to do a lot of investment for my uh, startup in the initial phase itself. And for many of the startup or for small businesses, this could be a huge amount. So what is the solution? Well, the solution is in the form of cloud. You might have seen these types of images or videos in movies or on internet. So where you have got acres of land, you have data centers spread across acres of land, and there you have such types of rooms, server rooms, where you have racks. In each of these racks you have stacked multiple server, right? So whatever applications you are using, be it social media, e-commerce, anything, so these guys have also set up their, or I can say deployed their applications in one such cloud system. What they do is they just rent these systems as per their requirement. They don't have to do any initial investment in the hardware or the real estate, right? There are big names such as Amazon Web Services, Microsoft Azure, Google Cloud, etc. So they do provide such kind of cloud services. So you can just rent their services. Now, what kind of services they do provide? One of the most important one is storage. Another one is compute power, that comes in the form of servers, right? Storage, when I'm saying storage, it includes both files as well as database storages. So at a fraction of cost, you can literally deploy your solutions into such cloud system. So these are some characteristics of cloud system. They are easy to maintain as and deploy, as you don't have to physically own that setup, right? It is quite cheaper. As I have mentioned, the initial investment is on the lower side. And on demand, let's say maybe during a particular festive season, you are expecting a huge number of requests from the customers. Then in that case, you can easily scale up, or whenever required, you can scale down your infrastructure. So based upon how much amount of usage you have, that cloud computing platform will charge you accordingly. So there are services usually, they charge based on uh, our hours usage, etc. Then there are many other features. Again, I will uh, I will skip these points as it is a demo session, and let's focus on few more topics which I have to cover. So one of the quite popular, or I would say market leader when it comes to cloud computing platform is Amazon Web Services. And hence I have also selected this platform for our data engineering course. There are other platform as well, such as Microsoft Azure or Google Cloud, IBM, Oracle, etc. But see, if you get if you get the understanding of one cloud platform, it is quite easy for you to pick up uh, rest of the cloud platform, right? Because concepts are same, only what changes is the name of services. So as I was telling you, AWS is a market leader having a global presence. And though these services are chargeable, but I will tell you a hack going ahead, that you can access all these services at a free of cost. Well, in this particular screenshot it says 12 months free access, but recently they have changed their rules, and now it is no more 12 months, but for first 6 months you can use majority of the services of AWS relevant to our course for free of cost, right? And and in case by mistake, in case if you failed to turn off any particular service once your usage is done, and maybe after you have consumed the free limit access of that particular service, they may charge you, right? So I will also tell you a hack how you can waive off your only first bill from AWS. So it is not just about learning concepts, right? But also some few tips and tricks which will help a lot of you going ahead. So for example, this is a particular diagram of one of the project that we which I have planned. So you could see there are various services of AWS uh, which we will use for our data engineering project. So some of them include storage systems like S3 bucket or DynamoDB, RDS database. So you can have any one of these as a data storage. And then there are few services such as Glue, right, through which you can do the data transformation, and finally you can analyze the final version of the data through some dashboards, or by writing a Python script to generate the reports. Okay, that was all about cloud computing and data engineering. So now let me take you through another concept called as distributed computing system. As I've told you in the beginning itself, I'm you know I'm not covering a particular topic. In this 1 hour session, I will address multiple topics. Another one in this list is distributed computing system. So in our course, we are planning to build data engineering solutions using something called as PySpark, a tool used for uh, big data problems, right? So what happens, earlier I have shown you a diagram of client server architecture, right? So there you have one client machine and one server machine. Obviously you can scale up that system, no doubt, but it has some limitation, especially like softwares like, let's say, Excel or any other production grade database for that matter. They have limitation when it comes to data size. And we know, as nowadays we are having a lot of amount of data, huge velocity of data, etc. So in that case, those traditional systems are not capable of not only storing that data, that huge amount of data, but they also fail to process the data. For example, let's say I have uh, I'm building a software for insurance domain. I have details of millions of customers, like height of a person, weight of a person, right? So obviously you will have so many factors, so many parameters related to that patient, but I'm just considering these two for now. So with traditional storage mediums such as simple files, data files, or databases, you will face challenges while storing such a huge amount of data. And not only that, maybe you going ahead, maybe you want to uh, you build an AI system that predicts uh, whether to approve or reject that insurance claim. And to build that AI model, maybe you want to you need to create a new column in your database, in your data set, called body mass index. We know that body mass index can be calculated using height and weight, right, of a person. Now again, here the traditional system faces challenges to perform such a huge amount of computation for those millions of rows of data, right? So here comes distributed computing system into picture. You might have also heard of, in addition to PySpark, Hadoop, right? So all these systems basically use this distributed computing architecture. So in just a matter of 4 to 5 minutes, I will explain you this diagram, and then we will move to the next topic. So let's say I have a data file. Okay, this is my data file. Let's say its size is 100 GB, right? So this is called as cluster. In this cluster, you will have lots of computer machines. You can think of them as computer servers, right? One of the machine is this master node. Okay, and then you can see that there are racks, as I have shown you earlier. These are racks. The green color boxes are racks, and within those racks what you see is something called as worker nodes. Well, this is a name given to that machine, but it is nothing but a computer machine, worker node, which basically stores and process your data, right? Now I not only want to store this 100 GB of file, but in the future I also want to ensure that I should be able to do the data processing and get the results in the real time. So how this distributed computing system manages such type of data? First of all, it will split my data into smaller chunks, as you can see. So this is my single file. I will it will uh, break it into multiple chunks. Each of this chunk can be of let's say 128 MB or 256. So it is up to you to decide the size of that chunk, right? And then through this master node contains the information, metadata about all the worker nodes, all the servers, all the computer machines involved in this cluster. So it knows which computer is having a sufficient storage system, which computer is having a lot of computation power currently available. So based on that, what it will do, it will, let's say we have divided this huge file into multiple chunks, chunk number 1, chunk number 2, and so on. What this master node will do, it will store all these chunks across these worker nodes. So in this way, we have solved the problem of storage, because earlier it was not possible to store a single file into a single machine, right? I mean, 100 GB you can store on the hard disk, but when it comes to processing that file, we may not have 100 GB RAM, right? So that was the challenge. So you can see that in this way we have stored all those chunks across different machines. One more thing that you might have noticed, this chunk number 1 is replicated across multiple worker nodes. Now why this model of replication is being used? Same goes for chunk number 2, you can see that it is available here also, and for rest of the chunks we have followed the same strategy. The reason for this replication of data is to ensure the reliability of the data. What happens if this particular machine goes down due to power issue, due to network issue, or maybe due to some hardware failure, right? In that case, what will happen? You will lose that data, right? We don't want such type of systems for our production applications, right? So there comes replication for help. So since I had a backup of the data, located into some other system, so we can quickly use that. So that is one issue that we have solved the issue of storage, and through replication factor we have attained the reliability, right? And not only that, as I was telling you, if I have to calculate body mass index for all those millions of patients, I'm just giving you one example, that is body mass index, but in real world scenario you might be performing some complex calculations, right? Now if I have to calculate this body mass index, so this particular computer, let's say it has to do the computation for only 10,000 patients. This particular machine, let's say it is calculating BMI for, let's say, only 2000 uh, users. So now you can see that we have distributed these uh, calculations or this processing, data processing, across multiple machines. So imagine, instead of doing that data processing on a single machine, right, it will take hours or maybe days depending upon the complexity of calculation and the data size. But now that we have distributed that operation across multiple nodes, we are able to achieve our result in a shorter time. So the speed of processing has increased through this distributed computing system. I hope this concept is clear to all of you. So this is an architecture, theoretical architecture, and as I was telling you, this PySpark and this Hadoop system, they uses this architecture, right, to achieve the scalability, to store the big data, to store and process big data. So we will see a lot of PySpark code functions, through which we can do such type of data processing. Yes, Diksha. So, as far as such type of systems are concerned, either you can install PySpark on your local machine, right, and get your PySpark code executed, or you can also use Databricks like system. So I have planned, to use Databricks, uh, although they have a they ask for paid subscription, but we can all but for the learning purpose we can use their uh, community edition, which is free for almost 2 weeks. So I think 2 weeks is more than sufficient for us to explore that platform. So we can, we can create account over there and we will execute some PySpark script on it.
Okay,
Diksha.
Nile sir, I have a
Yeah,
question over.
yeah, please.
Just I was combining all. You said like there in the cluster there are nodes which carry duplicates and data to be go through the master node, and
Correct.
how if the main if one you're talking about the in first node, I will say one data is corrupted. Then how we will get to know that in the other we have like in the worker node our data is over there is like link like a primary key or something like to fetch the data. How the reliability will increase by this and the speed as well increase by making into the chunks.
Okay. So, Sanchita, sorry.
Sanchita.
So,
Yeah.
yeah, yeah. Yeah, so Sanchita, there is something called as config file, right? So in any of such system, you have a config file where
Mhm.
you mention the different properties related to your architecture. So this may include, the chunk size. This may include the replication factor, etc. Right? So that is one thing. And uh, and about your question that what if some a particular one goes down, then you don't have to worry about that how a system finds the replica of this chunk number one. It will happen automatically. So this system is smart enough to to handle such type of catastrophic events. You don't
Mhm.
have to manually dictate each and everything.
Okay, so I don't have to like worry about my queries when I am running to fetch the data.
Yeah, yeah, yeah,
Okay.
One question, Nilay.
yeah, yeah,
So,
please.
the data is being duplicated, right? In that scenario, meaning
Hmm.
we are allocating extra space in the storage.
Hmm.
Um, so, how many such instances will be there? Meaning, let's say chunk number one, okay? How many chunk number ones will be there across that
Okay,
worker
okay,
nodes?
okay. So that you can mention in your configuration file. Oh, sorry.
Okay.
In your configuration file, you can mention the replication factor. Uh, in most of the cases, I have seen three, but depending upon your requirement, you can decide that.
Okay. So let's say I'm an insurance company and I'm using AWS for instance.
Hmm.
Um, so let's say if I put that chunk number one in all the worker nodes, right?
Hmm.
So it will slow down my system, right? Like let's say if I query or if I get some data, trying to get that data. So will there be any limitation for it?
Okay, you mean to say that, let's say you have got 100 worker nodes, so you will create 100 replicas of chunk number one
Correct.
across cluster. Usually we don't follow such practice because then you will have too much of data duplication, and as you have pointed out properly, that it may cause speed issue, right? So
Hmm.
usually we don't go for such a high replication factor. um, yeah.
Okay.
Yeah. And
Okay, so there is no limitation for it, meaning I
Meaning
can do that, but it's not a good idea to do that, right?
yeah, 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 true.
Okay.
And 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 remember, even though we are saying that I mean, one of your question was about, I think, even if we have replicated data, it may slow down the system. But remember, now, in earlier discussion, I mentioned that there is a single system, only one single system processing all 10 million rows of data, right? But now
Mm-hmm.
what is happening, that each of these machine may be having relatively lower hardware configuration, but it is capable, but it doesn't have to process hundreds of thousands of rows, right? It just have
Mm-hmm.
to process few a few thousand rows. So they have that capacity, right? So instead of
Mm-hmm.
running that query for hours on a single server machine, we can execute such query, and maybe each of these machine may take just few minutes, right?
Okay.
So all these processes are running in parallel. So that is going to be
Okay.
the advantage of this system.
Okay. And coming to the configuration file that you mentioned,
Mhm.
so who will be doing it? Like, will AWS maintain it, or the insurance company employees will be maintaining it, or the one who is
No,
using the AWS?
we can edit that information.
Okay.
Yeah, yeah. And
Got it.
so AWS, AWS, when you create a Databricks account, they ask you which cloud platform you want to use. Let's say I selected AWS. Then going ahead, in through Databricks, I can create such cluster. I can add three, four. It is up to me how much amount of machine I need, worker nodes, and then so all that configuration will be done whenever we are doing the setup.
Okay.
Yeah. All right. So that was all about introduction to data engineering, and then we have seen cloud computing, and then distributed computing system. Cool. Now, obviously, for the sake of this course, we will be doing installation of Python and relevant software into your machine. But since this is just a demo purpose, for the sake of demo, I'm just using this Colab from Google. It's an editor in which you can write your code. So you can just, I will share this link in the chat box for your reference. And here we click on new notebook to create a new file to write a code. So you can write Python code in .py file where I don't know, may I know how many of you are already uh, aware of Python? You have used Python. Just type Y in the chat box. Okay, Diksha is saying yes. Fine. So you can write Python code in a simple .py file, that is Python file, or an alternate way is to use such IPYNB files, that is interactive Python notebook. Now, what is the advantage of using these types of files over regular coding file is that you can execute a small snippet, just a small snippet of your code at a given time. Observe the output, right? Because in data engineering, you may have to analyze the result, then again make some changes in the code, as the results are not expected. So even for the data scientist and data analyst, they also follow this notebook files for their Python script. So this is the user interface. Okay, now I can see that now they have also added this uh, Gemini feature in this one. We will not use it because I strongly believe if you want to learn something, at first you should do the coding manually, and once you are comfortable with that technology, you can eventually use AI to build the system in a faster manner. Okay, so what do we have here? Let me open open board. Going ahead, we will be using a similar or I can say a similar type of IDE called as Jupyter Notebook to write Python script. It has got a same interface. Everything is same. Only the thing is that it runs in your own local machine instead of on the cloud. So what we have here at the top is a file name which you can edit with just simple mouse click, right? This is file extension, this is file name. Then you have got menus over here. So from file menu you can open your existing code files or you can create new one, right? And this particular thing is important. It is called as cell. So in this cell, in a single cell, you can write one or multiple lines of code and execute that code by clicking on this run button. Or what I personally follow is I think it's shift plus enter. So what this shift enter shortcut key does is that whatever code I have written, it will execute that code. Not only that, after successful execution of the code, it will create a new cell for me wherein I can write my next line of code, right? So that's a brief introduction to this particular coding platform. And when it comes to Python, it's a very interesting programming language, and it is quite popular amongst data and AI ecosystem. So majority of the data engineer role, data scientist, and AI engineer role, Python is a must-have skill for them. So since we are running out of time, I will just take a very basic example, right? In case if you are coming from Java, C Sharp, or C++ background, you must be knowing that if you even if you write just a hello world message, you have to you have that boilerplate code. You need to include few libraries, then you have to declare a class, a main function, etc. But this is not the case with Python. As you can see here, I can simply write the relevant code and just get it executed. So that is one of the simplicity. You can also see here that I haven't mentioned the data type for variable X. You can, by the way, check if it is integer or something else. So you can see that. So Python is a dynamically typed language, which means that at runtime the data type is assigned to this particular variable depending upon whatever value content are, right? And then typically, for example, let's say x equals to 10, y equals to, you can simply do the calculations as you might have done in any other programming language. You can replace this code with calculation of body mass index, right? So you may have in height and weight as input, and then you can calculate body mass index. This is interesting feature of these notebooks. You don't have to explicitly use a print statement to check the content of a variable. At the end of any cell, if you just mention the name of that variable, you can see its value content, right? One last example. If it is less than, it means it is a negative number. Again, for those who are coming from Java like languages, right? So this syntax might be a little bit different for you, right? So in case of Python, they don't have pair of curly brackets, or they use right indentation, as you can see here, right? And one more major difference over here is there are no semicolons after each statement, right? So there are lots of programming constructs which are used in Python, which makes quite easy for a beginner to learn and implement that Python code. And this is the reason that uh, many domain, be it finance, pure sciences, etc., they have those people from those domain have learned Python, build their own packages. So you have tons of ready-made libraries for most of the tasks that you want to perform. You don't have to write code from the scratch for every time. And going ahead, when we will do data processing, I will introduce you to some uh, libraries, Python based libraries, that help you to do the data analysis, data visualizations, etc. All right, so that was a short introduction to Python. So as Sanchita, control enter is also an option. Let me show you. For example, if I type print, okay, now see here what happens. If I press control enter, that cell is getting executed, fine. But usually what happen, you after executing this code, you may want to add a you may want to write a new piece of code, and for that you will have to now explicitly go over here and add a new code cell. So to avoid this, what I do is I use shift enter, because the moment you use shift enter, it also creates a new cell for my next line of code. That's the only difference.
Okay. Yeah, that I checked. Yeah, it's not coming up, so we have to need to add code line.
Yeah.
Neele, one question. So,
Yeah.
does this create do the auto indentation, or do we have to do it
No,
manually?
that you will have to add by yourself.
So, how many spaces should be there after you for the next line?
Single tab is sufficient. Now, depending
Okay.
upon the code editor which you are using, for example, here you can see that it is using 2 characters. In case of VS Code, I think it is 3 or 4 characters by default. That setting can be edited. I mean, that's not an issue. What you do is you just press tab after that. And let me show you one more example. For example, I equals to 1. Okay, while I less than 10, print I. So this is a classical example of loop, right? Again, here you can see that instead of curly brackets, we have those right indentation. I equals to I plus 1, right? So just make sure that whatever is the part of while body, if body or else body, just write that code with indentation. And,
Okay.
and,
Can't
and
we select all and then click some button to auto indent?
yeah, that is also possible, but nowadays these IDs are smart enough. See, I was able to select all the lines within while body, and then I press tab button, right? But what happens here is that, see, these IDs are smart enough. When it detects that I'm writing while loop, if else block, right, or any block kind of programming structure, you
Mm-hmm.
have to put those colons, and the moment you hit enter, it will
Okay.
automatically take those indentation.
Okay. Got it.
Yeah. So it's a part of it's a matter of practice. I can assure you, in just a matter of week, you will be quite comfortable with Python. All right, so that was about Python foundation. And yeah, I had so many things to discuss, but let's limit ourselves considering the time constraint. uh, I will now I will take you another 5 minutes to explain you the most simplest AI ML model. So I hope you might have heard of term machine learning, right? So we have, this is your AI system, okay? I'm using a Venn diagram to explain you the relationship between AI and ML. So using AI system, we can automate any manual task, right? And it is estimated that uh, all the emerging technologies will use AI in some or another form. And within AI, you have a subset called as machine learning. So these are machine learning models, or kind of AI model, that use concepts like statistics, uh, linear algebra, etc., to build few algorithms. So these models are nothing but algorithms, or I can say some mathematical equation. And through that equation, you can establish the relationship between input and output. I think I have, yeah. So here is one example. So let's say we all went to a mall to buy apples, right? And this is a quite old slide from my presentation. So I have considered that a price of each apple is, let's say, 10 rupees, which is not the case, but we can consider these numbers for hypothetical example. So if a person is buying a single apple, the total price for the apple is 10 rupees, and let's say uh, that person have to pay additional parking fee of 20 rupees, so the total price comes out to be 30, right? So likewise, for those who are going for 3, 5, 10, etc., these are the corresponding final amount that they have to pay. Now if I represent quantity with X and final price with Y, then can I establish the relationship between X and Y in the form of mathematical equation? Yes, it is possible. See here, Y equals to 10x. X is the quantity of apples that you are buying, and 20 is the parking fee. Doesn't this equation look familiar to you? Y equals to mx plus c. It is a equation
Algebra.
of line.
Mm-hmm.
Yes, linear equation. Correct.
Mm-hmm.
So what do you mean by this linear equation? Or let's say, I'm using this 2D plot. Whatever data we had inside that table, I'm just plotting it. Let's connect all these data points, and what you get is a straight line. And this straight line satisfies the equation y equals to 10x plus 20. Meaning that if we consider any data point, okay, any data point on this line, it will satisfy this equation. Its corresponding x value is 6, right? So let's put the value of x equals to 6 in this equation, and you will see the value of y comes out to be 80. So I have done the calculation in a mathematical way using equation, as well as geometrically I have proved that for given input of value 6, the corresponding output is going to be 80. What AI model does is that it basically learns this pattern hidden within the data. For now, this particular line is nothing but your machine learning model called as linear regression, and it is represented by this particular equation. I know it's a very it's a toy data set, but with such a simple two-dimensional data, I can easily explain the mathematics behind it. With higher dimensional data, it becomes quite difficult to understand the mathematical calculations happening in the background. So what we are going to do in this course going ahead, we will build such ML model to build, to make predictions about some real world data set, right? Maybe related to e-commerce, logistic, etc. Or let's take the example of insurance, right? So in case of, we can build machine learning model using PySpark to predict if the incoming insurance request should be rejected or approved, right? So for that, obviously you need the knowledge of this, the mathematical knowledge. See, no one is going to ask you in detail the mathematical derivation and all that, but having the background knowledge of that, the mathematical intuition behind that model will come handy, and then you can easily identify for given particular problem statement this ML model will perform better compared to the other one, right? So I'm not going through all this content again, but I have few slides wherein you can see that how I am building intuition behind that linear regression model, right? And it's nothing complex. If you know 10th level mathematics, you can easily understand it, and no need to remember all this derivation. You just need to understand what the maybe in I can give you summary of each model in just 2-3 lines, and you just need to remember that. That's it. All right, so I think I have I think I have covered everything. We started with just a minute. So we started with the concept of data engineering, right? And I kept it as simple as possible. Don't want to use jargons and don't want to bombard a lot of heavy technical concepts in the session, right? So we started with the concept of data engineering, followed by we have seen the concept of cloud computing, and there I have as I've mentioned, we will using AWS cloud platform for all our practical examples wherever applicable. Then we talk about distributed computing system, right? How it is able to store more amount of data, and it has a capability of fault tolerance. It can process the data at a much higher speed. And one thing, I think one point I forget, that now why PySpark? Why not go with Hadoop? So Hadoop was there; it was quite popular back then. But the major advantage of PySpark is that they store the data in the main memory, that is RAM. So there is so in case of Hadoop, what used to happen, you have to load the data from hard disk into main memory, and then the processing used to happen, right? So but now that the PySpark stores the data in the main memory itself, and now we have relatively advanced hardware configuration. We can have a RAM having 64 GB or 100 GB, right? More than 100 GB in size. So that data read write operation is not there, and as a result of which, compared to its competitor, PySpark can be up to 10x faster. So that's why it's a quite industry standard nowadays to use PySpark for most of the data engineering pipelines. Okay, so we discuss about distributed computing system. After that, what topic we have covered? Was it? Yeah, okay, Python. Yeah. So that was just a very simple example, performing few addition. But I hope those who are not from the Python background, you could relate to that code, and you could see that it was relatively, it is making use of lesser programming constructs such as semicolon, brackets, etc. Right? Then data type declaration. So you could see that writing and reading Python code is relatively simpler, and you will enjoy this journey of learning Python and building your data engineering solutions with Python. Last but not the least, I have shown you example of theoretical. Though we discussed the theoretical part of machine learning, but eventually we are going to use PySpark to build one such ML model, right? So we will process the data through our data engineering pipeline, and then through PySpark we will make predictions about a particular use case, right?